This is Janna Gajjal, Assistant Professor at IT/ICT Department of LG Institute of Engineering and Technology. Welcome to the 5th lecture of Unit 6. In previous lecture, we have discussed about testing strategies, in which we have discussed about a unit testing. Okay, so we have defined that there are 4 testing strategies, that is unit testing, integration testing, validation testing and system testing. So in previous lecture we have done with a unit testing. Okay, so in unit testing we have discussed that in unit testing components are individually tested. Okay, so here if you have a huge project, then you are checking for each and every component of your software product. Okay, so that is about unit testing. Now in today's lecture we will learn about another testing strategy, that is integration testing. So in previous lecture we have discussed that integration testing is a combination of components. Okay, so if you have many components and you are combining all components and do some testing for all that components, okay, so that is the integration testing. Okay, so integration testing is a level of software testing where individual units or components are combined and tested as a group. Okay, so you are testing in a group. Okay, so all the components are combined together in a group and you are testing for the particular group. Okay, so it is the process of testing the interface between two software units or modules. Okay, so if you have a module A and module B, then common features of that particular module, if they are integrated properly or not. Okay, so is there any link between module A and B? So you are combining module A and B and you are performing some testing. So that is the integration testing. Okay, so the main objective of integration testing is to take unit tested component. Okay, so as an input you are taking unit tested components and build a program structure that has been dictated by software design. Okay, so here after completion of unit testing you are taken the unit tested component as an input, you are grouped together. Okay, so you are doing grouping of that particular component and you are applying some testing. Okay, so that is the integration testing. So the main focus of integration testing is to uncover error in design and construction of software architecture, also integrated function or operation at subsystem level, interfaces and interaction between them. Okay, so how that particular one module is interact with other, how they are interacting with other modules. Okay, and also you are testing for resources integration and or environmental integration. Okay, so this is all about the integration testing. Okay, so in integration testing you are testing for a group of component. Okay, so in integration testing it can be carried out using 2 approaches. Okay, so first approach is a non-incremental integration and second is incremental integration. Okay, so integration testing approach is divided into 2, that is non-increment integration, in which there is a big bang strategy, and for incremental integration there are 4 different approaches, that is top-down testing, bottom-up testing, regression testing and a smoke testing. Okay, so let's understand each and every testing in a brief. So first, that is non-incremental integration, in which there is a big bang testing. Okay, so big bang testing is an integration testing approach in which all the components or modules are integrated together at once and then tested as a unit. Okay, so here all the components are grouped together and tested as a unit. Okay, so this combined set of components is considered as an entity while testing. Okay, so you are testing for one entity. Okay, so if all the components in the units are not completed, the integration process will not execute. So in Big Bang you should complete your software product first. Okay, so for Big Bang testing your product should be a complete product. Okay, so if all the components in the units are not completed, then you can't perform a integration testing, means you are not allowed to perform any testing for that particular product. Okay, so this is about the Big Bang. There are some advantages like Big Bang is convenient for a small system. Okay, so if you have a small project, then you can apply a Big Bang testing. Okay, and there are many disadvantages like it is hard to debug. Okay, so if you have a large project and you want to debug the project, then it is hard in a Big Bang testing. Then it is not easy to isolate error while testing. Okay, because if each and every components are not completed, then you can't perform this. Okay, so it is not easy to isolate error while testing. In this approach, it is not easy to validate test result. Okay, so if you have done testing, then it is also difficult to validate your test result. And since the integration testing can commence only after all the modules, the testing team will have less time for execution in the testing phase. Okay, so as we have already discussed that we need a proper complete version of your product. Okay, so since the integration testing can commence only after all the modules are designed, the testing team have some limited time for completion of the particular software product. Okay, so this is all about the Big Bang testing, in which all the components are verified and all the components must be completed before the testing. Okay, so this is all about the Big Bang testing. Now let's understand our incremental testing. Okay, so another strategy of integration testing is incremental testing. Okay, so in the incremental testing approach, testing is done by integrating two or more modules that are logically related to each other and then tested for proper functioning of the application. For an example, if you have done with the login page, you have to develop a sign up page. Okay, so sign up and login page is logically connected with each other. Okay, so if you have done sign up, then and then you are able to log in the particular website. Okay, so incremental testing is done by integrating two or more modules that are logically related to each other. Okay, and then you are performing some testing, okay, for proper functionality. Okay, so then the other related modules are integrated incrementally and the process continues until all the logical related modules are integrated and tested successfully. Okay, so for better understanding, let's take an example of e-commerce website. Okay, so if you have add any product to the cart, okay, so if you have product in your cart, then what is the actual process? So your product is ready to buy, then you are check on the buy button, then it will ask you for the address, on which address you want that particular delivery of the product. Okay, then after the payment gateway. Okay, so this is all the process. So in incremental testing, you are first checking for add to cart portion. Okay, so that particular module is working properly or not, then you relate it with the address. Okay, so if you have some product in your cart, then and then you can select your address. Okay, so if you don't have any product in your cart, then there is no need of address selection. Okay, so you are checking for address. Then if you have done with product and address, then you are performing some payment method. Okay, so this all the components are logically connected with each other. So the other related modules are integrated incrementally and the process continues until all the logical related modules are integrated and tested successfully. Okay, so if you have developed three different modules for add to cart, then address, and for payment, so you are checking for individual, so unit testing that you have done for each and every module. Then now you are incrementally added both modules. Okay, so first you are integrating module 1, that is add to cart, with the address module. Then if they are working properly after integration, then you are checking for that particular module with the next incremental module, that is payment module. Okay, so this is the whole process of incremental testing. But in incremental construction strategy, it includes 4 different strategies, that is top-down integration testing, bottom-up integration testing, regression testing, and a smoke testing. So let's understand each and every testing strategy in a brief. So first is a top-down. Okay, so as the name suggests, it is a top-down approach. So top-down testing is an incremental approach in which modules are integrated by moving down through the control structure. Okay, so high level modules are tested first and then low level modules are finally integrated, the low level modules to high level, to ensure the system is working as intended. Okay, and stubs are used as a temporary module if a module is not ready for integration testing. So here in top-down approach, you are incrementally checking for starting from main program to the sub program. Okay, so high level modules are tested first. That means module 1 is tested first, then after you are checking for module 2, then 4 and 5, then after 3 and after 6. Okay, so this is how the particular top-down approaches work. Okay, so high level modules are tested first and then you are integrating that particular low level module to the high level. Means if you have tested module 1, then you are integrating module 2 and 3 with the module 1 and you are checking for module 1, 2 and 3. Okay, then after you are integrating that particular module 2 to 4 and 5 and particular 3 module to the module 6. Okay, and you are checking for the whole product. Okay, so this is how the top-down approaches work. And if you have not completed your sub-modules, then you can use a stub. Okay, that we have already discussed in our previous lecture. Okay, so stub is a dummy sub-program. Okay, so stubs are used as a temporary module if a module is not ready for integration testing. Okay, so if you want to check whole your project but module 4 and module 5 is still remaining, then you can use stub for module 4 and module 5. Okay, so you can check your system. Okay, so this is about the top down strategy. Now the next is about bottom up. Bottom up means you are applying bottom up approach, means down to up. Okay, so in bottom up integration, the modules at the lowest level are integrated first and then integration is done by moving upward to the control structure. Okay, in top down you are checking for the main module. Okay, so that is the high level module. You are integrated for the high level. Okay, but in bottom up you are integrated with the low level. Okay, so in bottom up integration, the modules at the lowest level are integrated at first and then integration is done by moving upwards. Okay, so by moving upward through the control structure, and lowest level modules are tested first and then high level modules are finally integrated, the high level modules to low level, to ensure the system is working as a intended. Okay, so here you can use a driver as a dummy main program. Okay, so drivers are used as a temporary module if a high level module is not ready for integration testing. Okay, so here you are checking for lowest level module and you are integrating with the high level module incremental. Okay, so first you are checking for module 4, 5 and 6, then after you are integrating module 2 and 3, and then after you are integrating module 1. And if any module 1, 2 or 3 is still in a remaining phase of development, then you can use a driver. Okay, so driver we have also discussed in our previous lecture, driver and stub. So in top down you are using stub and for bottom up you are using driver as a temporary module. Okay, so this is all about a bottom up integration testing. Now another testing strategy is regression testing. So regression testing is used to check for defect propagate to other modules by changes made to the existing program. Okay, so if customer will demand you something new in between your project, but you have already developed different modules and you have redirected each and every modules. Okay, so if you have connected two modules like module A and B, and if customer demand you to change in module A, so it will automatically reflect to the module B. Okay, so regression testing is used to check the defect that propagated to the other modules by changing made to the existing program. Okay, so if you have changed module A, then you will check for regression testing. Okay, so in regression testing you are checking for whether is there any error occur after changing in the particular existing product or not. Okay, so thus regression testing is used to reduce the side effect of the changes. Okay, so module A and module B, and module B is fully dependent on module A, but if you are changing some components in module A, then is there any reflection of module A component in module B? That you are checking in a regression testing. Okay, so here you can see that like in an e-commerce website, sign up is directly connected with a login. Okay, so if you change in a sign up, then it will also reflect you in a login. Okay, so for an example, if you have define some components like you need username, email address, password for login purpose. Okay, so you are registrating yourself with using this particular component, like you are entering your name as a username, then you are entering your email address, and you are developing any password. But customer demand that I want a mobile number as a login, but you have not included the mobile number in the particular sign up page, so you have to change that sign up page. Okay, so reflection of that particular sign up page, so change in that particular sign up page will reflect to the login page. Okay, so regression testing is testing for some particular error that have propagated during the changes occur with the existing components, okay, or existing program. So repeated testing of an already tested program after modification to discover any defect introduced or uncovered as a result of changes in the software being tested. Okay, so here you are repeatedly checking for any error. Okay, so if customer demands something new and new again and again, so what you will do, you will apply the changes and you will check for the reflection. Okay, so you are checking for the features and functions of other module. Okay, so whether that particular reflection is occur any error in other module or not. Okay, so regression testing is done by re-executing the test against the modification application to evaluate whether the modified code breaks anything which was working earlier. Okay, so if your module B is properly working and if you are applying any changes in module A, so in regression testing you are re-executing the testing against your modification code. Okay, so you are evaluate that whether that particular modification break anything that is already completed on the early stages. Okay, so here you are checking for the modification. Okay, so anytime we modify an application, we should do a regression testing. Okay, so if you change anything in your existing product, then you need to check for the all the relevant modules. Okay, so if any modules is integrated with the particular modified module, so you have to check for all the things. Okay, so it gives you confidence to the developer that there is no unexpected side effects after modification. Okay, so if you are done with regression testing, then developer can ensure that there is no any side effect of the modification in other module. Okay, so this is about the regression testing. So now let's discuss when to do a regression testing. Okay, so if you have a new functionality that you are added in your application. Okay, so when new functionality are added to the application, you can do regression testing. For an example, a website has login functionality with your email. Okay, now the new feature is like you can allow a login using Facebook, Gmail or any LinkedIn account. Okay, so this is the new feature, so you have to check for the regression testing. Then when there is a change requirement, means if you have forgot your password, so forgot password should be removed from the login page. So you are changing, you are modifying your login page, so at that time you are also doing a regression testing. Then another scenario is when there is a defect fix, means assume that there is a login button that is not working, so tester will report a bug for the login button. Okay, and once the developer fix that particular button of login, so regression testing is performed after the developer will deliver the modification of the code. Okay, so once modification is done for the login button, developer will give that particular code to the tester to test the working of the login button. Okay, so at that time you can also perform regression testing because you have already tested this particular module. Okay, but now you are retesting this particular module, so here you can also use regression testing. Then when there is a performance issue, okay, that means loading a page takes 15 seconds, so it reducing load time to 2 seconds. Okay, so that is also done by using a regression testing. And when there is an environmental change, okay, that means you are updating your database from MySQL to Oracle. Okay, so you are changing a platform for your database. Okay, so at this time you can also do a regression testing as a testing strategy. Okay, so this is all about when to do a regression testing. And the last testing strategy of incremental testing is smoke testing. Okay, so the smoke testing is a kind of integration testing technique that is used for time critical projects wherein the project need to be accessed on a frequent basis. Okay, so on frequent basis you have to test your software, then you can use a smoke testing. Okay, so this test is performed after each build release. Okay, so if you have version 1 that you have developed, then you can perform smoke testing. Again you have developed another version, then you can perform again smoke testing. Okay, so this testing is performed after each and every build releases. Okay, so smoke testing verify build stability. Okay, and this testing is performed by tester or developer. Okay, so smoke testing can perform by any person, like tester can also testing by using smoke testing, and developer can also check for the particular software product. Okay, and this testing is executing for integration testing, system testing and acceptance testing. Okay, so you can perform software testing for execution of integration, system and acceptance testing. Now in smoke testing, what to test? Okay, so what kind of components or what kind of features you are testing in smoke test? Okay, so all major and critical functionalities of application is tested in a smoke test, and also it does not go into depth to test each functionality. Okay, so you are just covering a basic features and functions of your software product. Okay, and it does not include detailed testing for the build. Okay, so you are just testing for the basic features and function of your software. Okay, so this is about the smoke testing. So that's all for the today's lecture. In today's lecture we have discussed second strategy, that is integration testing, in which we have discussed two approaches, that is non-incremental integration and incremental integration. In non-incremental integration we have discussed about Big Bang. Okay, and in incremental integration we have discussed about top-down integration testing, bottom-up integration testing, regression testing and a smoke testing. So that's all for the today's lecture. Thank you.